Hi, here's a video about a simple electric motor I made. To make this motor I used a D battery, 2 paper clips, a disc magnet, a piece of cardboard, some tape, 22 gauge copper magnet wire, and a straw. I started with my straw and wound copper wire around it, and after I thought I wound it sufficiently, I wrapped the two ends around the loop a few times so that my coil wouldn't unravel, so I got something sort of like this. Then, I sanded off the coating completely from one end of the coil, but only sanded off half of the coating from the other end. I'll explain the reasoning behind this decision later. Afterwards, I bent 2 paper clips into a shape sort of like this, and the little circle on the ends will hold the coil as it rotates. Everything else was just a matter of assembly. I taped the battery onto a small piece of cardboard so that it would stay still on a tabletop, and also taped my paperclip supports onto the positive and negative ends of my battery. Finally, I just put a disc magnet onto the battery between my two supports, and the electric motor should just work after you put the copper coil between the two circles of the paperclip supports. So here I have my D battery, and I bent 2 paper clips to sort of this shape, and I taped 2 on both sides of the battery, and I placed a disc magnet in the middle, and I secured everything onto a piece of cardboard for stability. And here I have my coil made out of copper magnet wire, and just kind of stick it through the 2 holes on the paper clips, and then it just starts spinning by itself. Yeah. While the coil's in a vertical state like this, a magnetic field is created by the disc magnet. Though the exact shape might not be like these arrows, the general direction should be correct. And next, current flows from the positive end to the negative end through the paper clips and coil shown by the lime green arrows. And since the wire is insulated, the current will have to go through each individual loop within the coil until it reaches the negative terminal. The current flowing through the left and right sides of the wire is parallel to the magnetic field, so there will be no magnetic force. But the current flowing through the top and bottom parts of the coil will create a magnetic force, since it's perpendicular to the magnetic field. Using the right-hand rule, the direction of the forces can be seen as shown by the red, which will lead to a clockwise torque if looking from the negative terminal. This effect is present in each individual loop since the wire is insulated, which will increase the torque, and it's also why using insulated wire is important. The other parts of the coil will also balance out, which will ultimately create net torque while maintaining a net force of 0 in theory. In a horizontal state like this, once again you can see the magnetic field in cyan and the current in green, and using the right-hand rule, the direction of the magnetic force can be seen again in red. This time, the net force and net torque are both 0 since the force is either applied at the axis of rotation or it's parallel to displacement. The forces are also balanced. But since there's initial rotation from the torque provided while the coil was in the vertical state previously, the coil will continue to rotate. The reason why I sanded only half of the coating off one end of my coil comes to play when the coil rotates 180 degrees to a vertical state again. Unlike previously, which you can see here again just as a reminder, after the coil rotates 180 degrees, the current would actually travel in the opposite direction, and it would create forces shown here which would create torque in the opposite direction as well. So to eliminate this, only half of the insulation was sanded off so that while it's in this state, no current can be conducted because the insulation blocks it. And because of this, the coil will continue to rotate in the direction of the previous torque, which came from the first state. As a whole, the coil will be rotated by a torque while in the first vertical position, which I showed, and will continue to rotate because of the lack of net torque while it's in the horizontal position, and also because there's insulation while it's rotated 180 degrees to the other vertical position. In other words, torque will only be present in the first position, so the coil will continue to cruise along and rotate. This will cause the coil to continue to spin and convert electrical energy from the battery to mechanical energy, which is essentially what a motor does. Yeah, it's pretty neat.